Okay, sketching trig equations. So not solving, sketching this time. Okie dokie. So this is for the rest of the 14J worksheet. So now you're doing it properly, you're not just solving them, you're doing the whole sketch. Great. Well, we'll start with something nice and simple. Y equals 3 sine 2x. Okay? Well, there's a couple of things that we can steal out of this for free, straight off the bat. Firstly, amplitude is 3. Brilliant. Nextly, n is 2. Okay, well if n is 2, then the period must be pi, because 2 pi divided by whatever n is, that gives us our period length. Beautiful, so we've got 3 and pi for that. Great. Okay, we can solve this for x-intercepts as well. Okay, let's do that. So to get x-intercepts, we need this to be 0. Okay, 0 equals 3 sine 2x. Great, we can divide by 3. 0 divided by 3 is still 0, so I don't need that. When does sine equal 0? Got to draw my unit circle. This is what we were doing last time. Cool. When does sine equal 0? Well, hang on, that only happens here and here, so it's on multiples of pi. Okay. Well, that means that 2x must equal all the multiples of pi, so I'll just put negative 2 pi, negative pi, pi, 2 pi, dot dot dot. Great, well we still need to divide by this 2, dot dot dot, divide by 2, negative pi on 2, pi on 2, pi, so on. Great, okay, so we've got the basics of this. We need to go up and down to positive and negative 2 pi. At this stage I'm going to say that that's a pretty obvious pattern, it's just going up and down by halves. So we'll deal with that in a second. Great. Okay, this thing is going to be centered on 0. That's a terrible straight line. Yep, that's a terrible straight line, but I'll deal with it. Okay. Well, oh, I forgot 0 in here, did I? Yes, what a silly person. So there's always silly things that you can do. 0, pi, and this could go up to 2 pi. 0, pi on 2. There we go. Great. So we know that one of the solutions is 0. Sorry, one of the x-intercepts, I should say. Cool. Next, and then we've got every pi on 2. Okay. Well, if I want to make this go from negative 2 pi to 2 pi, let's say that's 2 pi. Does that look about equal? No. Now, the arish is about 2 pi now. That's about 2 pi. Cool. Halfway would be pi. Halfway in between that would be the half pi's. Not to be confused with half pipes. There we go. That's negative 2 pi, negative pi, pi, and then halves, obviously. Drop the textile lid. Okay. So we've got 0, pi on 2, and then negative pi on 2, negative pi, and all the multiples of half pi's. Great. Now, we have to think a little bit. What did basic sine look like? Well, hopefully we remember that basic sine of x equals y looked like that, where it starts going up. Cool. Well, we're going to start going up. I'll just draw it. Has to come back down through this, then back up, back down, back up, and similar story for the rest of it. Something like that. Great. Well, hang on, we need to know how tall this thing is. Well, that's what the amplitude was about. So that's 3 and negative 3. The last thing we should do is always check some other point that we haven't calculated, just to make sure it all works out. So what I'm going to suggest, this is pi on 2, so I'm going to think about pi on 4 and test that. If I put pi on 4 into here, 2 times pi on 4 would be pi on 2. Sine of pi on 2 would be 1. 1 times 3, 3. So y should be 3 when I put in pi on 4. Pi on 4 gets 3 back. Beautiful, I'm happy about that. Everything is consistent. Cool. Next guy. Well, similar story. Grab the stuff you can grab for free. Amplitude is 4. Remember, amplitude is just the positive value. Period is 2 pi divided by a third, so that becomes 6 pi. Beautiful. Blue. Cool. We want x-intercepts, so 0 for y. Okie dokie. We can divide everything by -4. That makes it nice and easy. Unit circle. When is cos 0? That would be up here and down here. I should have done that in green, sorry. It would be up here and down here. That's where cos is 0. So our inside, x on 3, equals 1, 2, 3, 4. Pi on 2, 3 pi on 2. Going backwards, negative pi on 2, negative 3 pi on 2. Now the fact that these were symmetric and these are symmetric aren't guaranteed always, but it will commonly happen. Cool, times everything by 3. So we've got negative 9 pi on 2, negative 3 pi on 2, 3 pi on 2, 9 pi on 2. Great. Well, we've got a domain of 6 pi. Alright, well, 6 pi would mean that we can add in some more. Notice that everything's a gap of 6 apart. So let's add in some more. Add 6, what do we get? 15 pi on 2, negative 15 pi on 2. Okay. Well, 6 pi on 2 would be 12 pi on 12. So that cuts out, great. So we've just got these 4 solutions. Okay. We're starting at 0 this time, so I'll put that there. So here's 0, and way out here is going to be 6 pi. Try to draw this at least roughly adequate. So this is 3 pi in here, and then everything's a multiple of pi all the way out, which I might as well write while I'm here. Okay. And we'll do half markers since we've got halves getting involved. Ooh, it's not exactly the scale, but you get the idea. Cool. Alright. X-intercepts. Okay, oh, actually, sorry, we went to 0. So we should have actually cut off there. My bad. 3 pi on 2, okay, that would be there. 9 pi on 2, that would be there. Okay, thinking about what basic cos looked like from before. Cos of x equals y. That looked like so forth. Okay, well, that would suggest that when we start at 0, we should be up the top. A good idea, which is something we would have checked last time, but we already knew it was an x-intercept, we should find out where this thing's y-intercept is. So to get a y-intercept, make x equal 0. So, y-intercept is -4 times cos of 0 on 3. Okay, cos of 0, that's 1, times -4, -4. So we should land way into the negative. We already knew that our amplitude was 4. That's -4. That's going to be +4. So we're starting down here. Obviously we must go up. Cool. Halfway in between here it must max out again. Come back down. And now the last bit is to figure out where it ends, which I kind of just gave away, but we'll do that to be sure. Cool. So we take our function, y equals -4 times cos of, we'll try 6 pi over 3. Yep. Cool. 6 pi on 3 would be 2 pi. Cos of 2 pi would be 1, because it's the same as cos of 0. 1 times -4 is -4. Yep, that lands there. So we end up with, yeah, we'll do it in that colour, why not? 6 pi, -4 is that endpoint. If we were being perfectly proper about it, we should label this as well. 3 pi 4, just to say that that's the highest it ever went. This one, since it's an intercept, it's kind of implied that it's already there. We should label all these intercepts properly, but since I ran through it with you, I'm pretty sure you guys know what I'm talking about. Beautiful, so that's them. Those are relatively straightforward because you've just got amplitudes and periods. Over here, we've got extra shifts going on. So, things to notice, we'll come back to that actually, we'll just solve them as we normally did. So first thing, amplitude 4, period is 2 pi divided by n, so 2/3 of pi, 2 pi on 3, whichever way you want to say it. Beautiful, we've got a restriction, yes. Cool, solve for x-intercepts. Okay, that'd be 4 sine 3x minus pi minus 2, so we're making that equal 0, great. Move the 2 across, divide by 4, so this is now going to be half. So I've got this, fantastic. Okay, sine equals something, so I need a unit circle. Sine is positive, that's up here. Critical angles. Okay, when does sine equal a half? That's pi on 6. So my inside equals, amongst other things, 1, 2, 3, 4, dot, dot, dot. Cool, first one, pi on 6. Next one, 5 pi on 6. Going backwards, 7 pi on 6. Oops. And 11 pi on 6. Cool, and we can continue that out as far as we want. But for now, I'm worried about solving for x. So I've got to add pi. Keep in mind, pi is 6 pi on 6. So I'm adding 6 pi on 6. So that actually becomes negative 5 pi on 6. Negative pi on 6. 7 pi on 6. 11 pi on 6. And so on. Divide by the 3. So I'll get rid of that. Change these all to 18s. Just to save myself a bit of board space. I would highly recommend that you actually write that, but it's up to you. Beautiful, yes, good. Cool, so we've got all of our solutions. Well, now we definitely don't have this nice symmetry of things. Okay, so we've got to be a little bit more careful with what we're doing. Well, that gap would be 8. That gap would be 4. That gap would be 4. So the next gap should be 8, and so on. Okay, well, we've got to figure out where to chop this thing off. Okay, well, let's go a couple down this way. So we've got negative 5 pi on 18, minus another 8, negative 13 pi on 18, minus another 4, negative 7 pi on 18, x equals negative pi 18, 7 pi 18, 11 pi 18, add another 8, 19 pi on 18, and then add another 4, 23 pi on 18. What was it, adding another 4? Cool, we need to get up to just pi. Okay, great. Well, here, we could have gone one more. If we go one more, it'll be another 8, which is going to be past 18 on 18, so we're going to stop there. Over here, 19 was too big, so we stop there. Beautiful. So that's dead, that's dead. So we've got all of our x-intercepts, okay? We want to sketch this thing between negative pi and pi. Oh, okay. Cool, centered on 0, which is convenient. I'm going to make this pi. Hopefully that's roughly equal. Cool, halfway in between, that's pi on 2. Halfway in between, it's pi on 2. We'll go quarters. Oh, that's not so even, but anyway. Hopefully that makes a bit of sense though. Now we're going to have to do a little bit of guesstimation because these are on 18s and I'm not measuring that perfectly. Cool, alright, well actually let's slot some numbers in here just for reference. So 9 pi on 18 would be a half, and this is going to be really close to the left side, this is going to be a bit bigger. That's fine, that's fine. So, no, we might as well put it in, why not? So what am I out of? 9 is 4.5, so 13.5. Negatives I should put. 9 is here. 14, and what happened to 13? 13's out here. So those are my markers. So I've got pi, which is the same as 18 on 18, is 9 on 18. Quarter of that would be 4.5 on 18, which I should put in as well. Oops. 18. And 4 pi on 18 is in here. Okay, so that's just to get some rough idea of where things should land. Okay, well, this is 1, this is supposed to be 4.5, so I'm way back here somewhere. 5 is only slightly bigger. 13 is very close to this. 17 is rather close to that. Okay, next bit is, where are we? 7 is almost exactly in the middle of these. It's slightly closer to this one. And 11 is the same distance away as 7. So about there. And there's nothing else on this one. Okay, great. Well, it's definitely not as obvious what's going on here because it's all got this weird spacing. Well, okay, can we think this through and see if we can get somewhere? Well, how about we figure out a y-intercept? Which colour did I do this in? Pink? Yeah, okay. Y-intercept, or did I do it in? No, I did it in green. Makes more sense. Cool, y-intercept for 4 times sine of 3 lots of 0 minus pi minus 2. Okay, 3 times 0, gone. Sine of negative pi, well, sine of pi is 1, sine of negative pi would be negative 1. So this is negative 4 minus 2, negative 6. Is that what I had? Oh, hang on, that can't be right, can it? Yeah, it is. Yeah. Yeah, okay. Hang on, let's just double check that. Sine of negative pi, yes, cool. Negative pi, so sine is talking about heights, yes. Negative 1, negative 4, negative 6, yep. It should be that's looking suspect, no it shouldn't. Did I stuff up something somewhere? That's always an option. Add pi, which is 6, yes. 5 by 3, no, that looks okay. Interesting. Double check. I think I've stuffed up that 0. How have I stuffed that up? Sine of negative pi, yes, is yes. Yes, that's fine. Might need to jump the video at this point. That's wrong. That can't be right. 0 minus pi. Sine of minus pi. Oh, sorry, minus pi is 0. Whoops, there it is. So this is minus 2. That makes a lot more sense. I was thinking of cos. What a silly person. Oh no, I was thinking of pi on 2, that's why. Oh, jeez. Anyway. Cool, sorry, so that should be negative 2, so that's down here somewhere. That's 0, negative 2 is that point there. We know from before that our amplitude is 4, so that's twice as big. About there. So that's now negative 4. Oh, about there is 4. Beautiful. Okay. Well, that means that this must come down through here. Halfway in between here must be where it turns around. Now, we've got to do an extra little thing. Okay. So, next thing we're going to do is think about how big and small this thing can possibly get. So yeah, okay. Sine, the biggest this can ever get is 1. Okay, 4 times 1, 4, minus 2 is 2. So the biggest this thing can ever get is 2. That's supposed to be halfway up. That's 2. Great, what's the smallest this thing can ever get? Sine, the smallest it ever gets is negative 1. Times by 4 would be negative 4. Minus 2 would be negative 6. So we need more space. We need to go all the way down to negative 1, 2, 3, about there, negative 6. Cool. Okay, well, this thing's going to come down and back up. It has to reach the bottom here. So, it goes through. Okay. Has to reach the top, which was 2 from what we decided before, then spin back around, down here, and where are we going to reach? Oh, because we're on 3, yeah, okay. Then it comes up something like that. We'll have to figure out exactly where that ends shortly. Maxes out at 2, so it has to hit 2, come back down. Minimises at 6, great, I've gone through my own working, but anyway, you get the idea. Up and over. And then this continues on for a little bit. For a bit. Down there. Cool, okay, well, what we really want to figure out is how far up does this thing go? Okay, well, to do that, we'll have to sub in x is pi. So, y equals 4 sine of 3 by pi, yep, pi, minus 2. That up. Okay, 3 pi minus pi, that'd be 2 pi. Okay, sine of 2 pi is 0. 0 times 4, gone. This whole thing just equals negative 2. So we end up with about there, pi, negative 2. There we go. Similar story, we can work this one. Exact same process, you put in negative pi. In this case, you happen to end up at the exact same spot. That won't always happen, but it has a tendency to. Because I usually set up the question so that you've got multiples of the period length. Beautiful. Last little bit, we should label off where all these maximums and minimums are occurring. Okay. Well, you can set this equation equal to whatever the maximum is. So you could set it equal to 2, solve it that way. That's one way of doing it. And then do the same but set it to negative 6 to find the minimums. There's actually a much faster way. Since we know that these things are symmetric, actually what colour did I do? Oh no, I did it in blue, okay. Since we know these things are symmetric, what we can do is say, hang on, I know where these two x-intercepts are, and it has to be exactly halfway in between those. Okay, well where were these x-intercepts that we never ended up labelling? This was 7 pi on 18, this was 11 pi on 18. Okay, halfway in between those would be 9 pi on 18, okay, which we can simplify. Pi on 2. Back this way, we had negative pi on 18, negative 5 pi on 18. Okay, halfway in between those would be 3 pi on 18, which simplifies to negative pi on 6. Sorry, not 0, 2. Because we're up here. Whoops, there we go. And then across here, halfway in between these, okay, where are we? 17 and 13, well that's 15, 15 on 18, 5 on 6. Negative. Cool. Another way we can check if that makes sense. How far apart are these? They're 4 pi on 4 pi on 6 apart, which we can simplify down to 2 pi on 3. Well, that's the period length, so that makes sense because the maximums should be 2 pi on 3 apart. And similar story you can check for that one. This you can do either the middle of the x-intercepts or you can do the middle of the maximums. Either way, up to you. So what have we got? 1 and 5, so 2, 3. So we have 3 pi, negative 3 pi on 6, which is negative pi on 2, negative 6. Over here, and I'm going to start to run out of space, but that's okay. Negative 1 and this, so that gives me 4 on 18, gives me 2 on 9, I think. Double check that. And we don't have the other one. Oh, we know that it's 19 from that though. So gives me a run of 5, 15 on 8, so 5 pi on 6, negative 6. Cool, alright. Can we check these? So halfway in between these. Can change this into a sixth. So this is 3 on 6, negative 1 on 6. So 4 on 6 apart. So 2 on 6 added to this should be pi on, should be pi on 6. I'm going to stuff that. Possibly, it's always an option. So this is 8 apart, I need to add 4, which is add 3, whoops, yep. That should have been pi on 6. That's why you always check. Okay. Going from here to here, that's 4 pi on 6, which simplifies to 2 pi on 3, so we know that that matches. and pi on 6 to negative pi on 2, therefore pi on 6 apart, again 2 pi on 3. So now it's complete. So completing these fully takes a lot more fiddling, and it's always a good idea to double check independently to make sure everything is the right spacing apart, because you catch errors exactly like that. And that's that. You will almost certainly make lots of errors. Use pencil to do your sketching, otherwise you can become quite maddening if you have to do the same thing 7 times because you didn't change from a pen. Cool. I fully expect there'll be troubles with this. That's fine. This takes a little bit of getting used to. Best of luck to you though. Email me when you get stuck. Cheerio.